Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi, so they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hello, yeah, good evening, everyone. Yeah, can you just mention in the chat box that I am properly audible and at the same time visible? I am sharing my screen as well, so let me know if everything is properly working so that we can very quickly start. Yeah, so hello, Naikaj, how are you? So today is your birthday. That's very great to you. Happy birthday to you. So, what age are you turning, Naikaj? Yeah, so I would like to say that Naikaj is one of the few students who are attending this session right from the very beginning in the month of December when we started. We started, I remember, on 5th of December. So yeah, I am seeing Naikaj regularly till the very end as well. That's actually quite phenomenal and extraordinary. So all the best, Naikaj. You are turning 24. That's great, Naikaj. So, Naikaj, how is your preparation going on for your interviews? And yeah, so all the other students who are present in this session, can you kindly please write your name in the chat box just to confirm your presence? And we will be beginning very soon. So today will also be a practice session related to graphs and trees. And in fact, in the month of December, we started with tree. We started with graph, and we have completed tree as well. So the last session, which was yesterday, we focused majorly on practice, and in this session also we will be focusing on practice. So today I have three questions, in fact, involving the concepts of graphs as well as trees. Okay, so yesterday we did a medium to hard problems. So today we will do easy to medium problems. Okay, and Yeah, so I would request every one of you to kindly check out in the description. There is something called as live mock DSM, which is basically a mock interviews for your interview preparations, right? So that will be scheduled. If you fill the form in the description, you will get your interviews, mock interviews scheduled at the through to the mentors at Geeks for Geeks. So that is called live mock DSA, which will happen on every Saturday. Okay, so you can check that out. Yeah, and apart from that, yeah. So and apart from that, we also have a dynamic programming series going on parallelly on this very channel itself on Thursdays and Fridays. Okay, so let's see any comment. Okay, hi Gaurav, how are you? So apart from that, can you all please kindly mention the college in which you are studying and the year in which you are in? Just just to make the session a bit interactive. Okay, so let's continue. Yeah, and I told about the dynamic programming series that goes on every Thursday and Friday on this channel itself, so you can check that out as well. And in fact, I would like everyone to kindly subscribe to our channel and like this streaming. You can't that link in the description. Okay, let me check. Um, just a minute. Hmm. Okay, so it will start from 28th of January on Saturday from 10 p.m. onwards. So that is called live mock interview, and it will happen on this channel itself. So you can subscribe to this channel, and then you will get notified about the if there are any announcement regarding forms about how to fill. Okay, if it is not present in the description, it will be updated later on. But I just informed you all that we will be having such a thing from the next Saturday onwards. In fact, this Saturday onwards on 28th. Okay, so so you have dropped your studies from after class 12. No worries, Naikaj. You can keep on continuing with your hard work. Yeah. So let us begin then with our studies today. So this is a small introduction about me. You can read on the screen. Okay. So let's start then. Today our first problem would be the name of the problem is possible path between two vertices. This is actually a easy problem. Today all our problems will be very easy because we actually did the difficult problems yesterday's session. So I'm pasting the link of this question in the chat box. Yeah. Okay, so let's see this question. So once you read this question, what I want you all is to just write a brief idea in the idea which you can take to solve this question. The question is actually very simple. In the question, it is asking that you are given a directed graph, and that graph has v number of nodes numbered from 0 to v minus 1. And also, you have e directed edges. So, the graph contains a v number of nodes and e number of edges. Now, you are given two nodes. The first one is your source, and the second one is your destination. Now, you are asked to find the count of the number of ways or paths from these two vertices in a directed graph. Okay. Another note is given here that this graph doesn't contain any multiple edges or self loops or cycles. Okay. So how will you do this? So anyone can briefly tell me the concept here. As you can see, if the number of nodes are 5 and the number of edges are 7, and this is our graph, So let's say our source is the node number 0 and our destination is node number 4. So there are four ways you can basically reach from 0 to 4. The first path is from 0, you directly go to 4. From 0, you go to 1 and then to 4. This is the second path. In the third path, you can start with 0, go to node number 2, then to 4. And in the final path, you start from 0, go to 1, go to 3, then 2, and then 4. So basically, there are four paths for this. Now, I want you all to think of a concept that will actually help you to solve. You have to return the count of number of paths from the source to the destination. Okay. So, any ideas regarding this? Nikaj, what do you think should I do? What do you think should be an approach to solve such a question? In fact, if you see in this question, it is marked as an easy category question. Sorry, it's a medium category question with an accuracy of 56%, and around 20,000 people have solved this question. In fact, variations of this type of question I have done yesterday as well. Okay, so that was a hard level question. So if you remember in yesterday's session, there was a question in which you had to find the number of ways you can reach the destination from the starting node, and also you in minimum amount of time. So every edge has a directed weight, and yeah, Nikaj, we will be using DFS, but yesterday's problem involved a modified version of Dijkstra's algorithm. Okay, so you had the edge weights present, so every path was taking some amount of time. So you have to find the number of paths that is taking the minimum amount of time. It's not like that you have to find the minimum amount of time, but in fact you have to find the number of paths which are taking the minimum amount of time possible. So that was a modified version of the Dijkstra's algorithm. Okay, so Naika, you're saying DFS. Can you just describe to me briefly how we will apply DFS? So, Naika, you are saying that if you find the minimum path among all the path, I don't get it very well. Like you don't have to find a minimum path or anything. You just have to find the total number of paths that are possible from the node number source to node number destination. That's it. Okay. So in yesterday's problem, we had to find the minimum time required, and then we had to find the number of paths taking care that amount of time. Okay, so Naikat, since you first said that we will be applying the concept of DFS, so that is actually correct. So as I just described in this question, this was our graph. So we start from 0 and then we go to 4. This was one such path. Then we go from 0 to 2 to 4, then 0 to 1 to 4, and then 0, 1, 3 to 4. So these are the number of ways. So the answer would be 4. Okay, so how we will apply DFS? Any ideas? Okay, so basically, the application of DFS. Anyone? Like, yeah, Gaurav is also saying DFS. Yeah. So let me tell you the concept then. So basically, what is happening is that what happens in a DFS, you start a depth first search starting from any given node, and that function is a recursive function which calls for the every adjacent node, and it keeps on going into the depth of your graph until and unless you are able to reach a null value or you cannot traverse any longer. So that is the concept of DFS. Let's see what Gaurav is saying. Gaurav is saying just move, and if we reach the destination, then update the answer variable. Yes, Gaurav, that will be our approach. But we have to take care of one thing. That thing is basically, let me give you an example. So if you're traversing any particular path, that path may also lead to another path, which may again lead to destination. So we have to count the number of ways. So it's not like that if you are able to reach a destination, You have to make sure that all such possible paths you are taking. Okay, so what do we do here? We have to use the concept of backtracking here. Okay, so what we do, we start from the node number 0, that is the source, and we try to update our, try to do a DFS. So we recursively call for the next node, that will call recursively for the for its next node, and let's say if we reach a destination. If we are able to reach a destination, I will store that path. So I will keep a valid counter, which will update to 1 if I will just increment it because I found a valid path. But let's say I reached a dead end, but that dead end is not my destination. So in that case, what will happen? I will discard that path and I will backtrack to the next best path that I can get, and then I will try to do the uh, do the DFS. So that is the idea. So if it is a valid path, I increment the count. But if it is not a valid path, I totally discard that path. So this is where the idea of backtracking comes in, and DFS will help us do it. So let me do a small dry run here. So what I do initially, yeah. So I initially start from 0, node number 0. I do a DFS call. So DFS will call for node number 1, node number 4, and node number 2. So node number 4 is basically a destination. So this is a valid path. So answer would become 1. Okay. Now after node number 1, it DFS call for 4 and 3. So node number 4 is a valid path. So this will be a valid answer. But when it goes for node number 3, it will call for 2 and 4. Okay, so this is also 2, and then it will call for 3 will call for 2, and then 2 will call for 4. So this path is also becoming a valid path. This is also a valid path. This is also a valid path. But after 2, this will call for DFS of 4. So that also becomes a valid path. So in total, there are 4 valid paths for this. So yes, Naika, yeah, your explanation is entirely correct. You said that we will be applying backtracking concept because if path not possible, then we backtrack from there. Yeah. So if you are reaching a dead end and that particular dead end means like DFS call is done, but you are not able to find a destination. It means that that particular path should be discarded. And by code logic, you can only discard a particular path if you are just backtracking from there to another path, which is may or may not be possible. So that is the concept. So the implementation is bit very straightforward. So let's see. Yeah. So the code is already typed here. Okay. So let's see the first and the very first step of the question. So this is the function in which we have to fill our answer. So the thing here is that this function count path is taking the number of nodes v. After that, it is taking an adjacency list as well to mark the number of edges, then a source and a destination. So as usual, since we are applying the concept of DFS, we must use a visited array. So I'm declaring a visited array in which I'm marking everything as false. Now I'm also declaring a variable called int part count. So this is declared as 0 because I will be updating my answer in this variable. Now every time I'm able to get a path, so every time my final node is reaching its destination, I will increment the path count. I suppose you all get it. Now finally what will happen after I will call this function called count paths utility. So this is a utility function which I have just created. So I'm passing my adjacency list, my source, my destination, my visited array, and my path count. So the entire logic is coded in here. Okay, so see this function very carefully. So every time we are entering into this function, I'm marking that node as visited as true. Now I'm checking whether that node is equal to the destination or not. If it is equal, I will increment my path count. Okay, now after increment my path count, it will come to this part. So I will mark that node as unvisited as well. Okay, because I'm done with that path. Because that is a valid path and I'm done with that path. Now it's time for any other path to go to that path. So if it is not a destination, what I will do, I will call DFS. I will recursively call this function for all of its adjacent nodes. Okay, so this is basically the marking the current index is not visited. This is the essential backtracking step. So every time I am reaching a node, I am reaching a dead end, there can be two possibilities. It is either a destination or it is not a destination. In both if it is a destination, I will just increment my path count. But if it is not a destination, I will not increment my path count. But I'm marking it as false because the thing is that if it is because multiple paths can be possible to the destination. So that is the idea here. I suppose everyone got it. Okay, so you are requesting for increasing the screen size. Yeah, okay, just a minute. Let me try to magnify this. Yeah, I have magnified my screen. So is this okay? Like, it's too much, I suppose. I suppose this the screen is the font size is big enough. Yeah. So this is basically an iterator. So in case if your node is not equal to the destination, you will just do the standard DFS part in which you will visit all the nodes of the adjacent node and recursively call for the function. So this is the yeah. And as I said, that this last step is the final important backtracking step because you are just marking that particular node as false, although it is visited, because there may be another path which is leading to the destination. So every time you are counting a destination, you are increasing the path count. Okay. So after the entire DFS is done, you will get your answer. So let's submit this question and check. Yeah. So as you can see, all the test cases are passing. So therefore, this question is correct. Okay. So any questions from this topic, or should I move to the next question? So Naikas, did you understand it? Gaurav, is that clear to you? You think visited is not necessary as I think visited is not necessary as it is non-cyclic. No, actually visited is necessary because see the DFS call. For example, if you are standing at node number one, then you go to node number two. So node number two will call for DFS for its adjacent node, which but one should not be called again, right? So that is the reason we have to mark one as visited because I don't want the node number two to go back to node number one. So that will just be an infinite loop and you will never get your answer. So that is the reason we are maintaining a visited array. Yeah, okay. So I have already pasted the link of this question in the chat box so you can try it out. So this is a medium level problem. So let's move to another problem. So this one will be an easy level problem. Yeah. So the next problem is basically there are two versions. The first is an easier version of this problem, and the second one is a medium version of the same problem. The so let's see the first. Let us solve the medium version, and then we will look into the easier version. Okay. So because actually the medium version of this question is not available on Geeks for Geeks, but in fact the article is available. Hmm. But the easier version is present. So let's see that. So the question is that you have to print the path from the root to the node. So let's say I give you a binary tree. You already know the root. Now I give you a node, just a valid node. Now I ask you to print the path starting from the root and ending at this valid node. So how will you do that? So in case if this is the root number 1 and this is the node number 7, so you will be maintaining from 1 you go to 2, then 2 to 5 and then to 7. Okay, so this is what you will follow. So your answer would be 1 to 5 and 7. So how will you do that? Yeah, hello Shubhajit. Is there anything like why are you sending this emoji? Is something funny? Did I say something funny? Yeah, let us continue then. So, any ideas, Naika? So, how we will solve this question? Route to node path. Okay. Yeah, so what I'm asking, Shubham is asking for me to repeat. So basically, the question is that you are given a binary tree and you're given a root and a node. So that node can be anything. Now you are asked to find a path. You have to print a path in the form of a vector, starting from the root and ending to the node it is given. So if the node number is given as 7, so you have to start from the root that is 1. Then you have to print a path from 1 to node number 7. So the path will be 1, then 2, then 5, and then 7. So you have to print in that order. How will you do this? The question is this. We need to use DFS as well as backtracking. Uh, yeah, we can use that, but can you just tell me? Yeah, we can actually use that DFS plus backtracking type of concept. But just explain it to me in a briefly. This question is done, I suppose. So let's me. Hi Ravindra, how are you? So, need to maintain a list of answer to store the answer which we visit using backtrack DFS. If reach the destination, then print answer. Else continue to backtrack and update list answer. Yes, Gaurav, you're entirely exactly correct. Empire is saying that you're not able to solve medium and hard level question. You can what you can do is try to do more and more practice. That will be helpful. Yeah. So, Naika, you need to follow top down approach. Like, can you explain a bit more? Like, what do you mean by top down approach in this case? Okay, so what Gaurav is saying is entirely correct. So you will also use the concept of backtracking because let's say we start from the root and then we try to go to the left. I store the value in a vector. Then again I try to go to the left. I store a value in the vector. So if I am able to reach my destination, I will print that. But let's say I reach a node in which I am unable to proceed further. In that case, I will backtrack. I will tell you the concept in a minute. Nika is saying we store the node value in a vector until we get a node value. If in between we get null, then backtrack and go for another. Yes, exactly. So, like I wanted to hear one thing which you all did not say. The thing here is that since a binary tree are left and right both, so which one will you choose? Will you go to left or will you go to right? So basically, there is a concept of in-order traversal in which you try to keep on going to the left and then the root and then the right. So basically, what will happen in this question also, we'll try to keep on going to the left. Okay, so let's see. So let's see what is happening here. You are at 1, and then you try to go to 2, and then you try to go to 4. Okay, so for example, so let's say you are standing at 1 and you are maintaining a vector. So initially, since you're standing at 1, you insert 1. Then you go to the left, you insert 2. Again, you go to the left, you insert 4. Now, when you are coming to 4, you see that both the left and the right are null. So what is happening? Therefore, you cannot proceed further. So now you will check whether the number 4 is your destination or not. So you see it is not your destination. It means that whatever values you have collected till now, it is wrong. It is a wrong answer. It is not a valid path. So what you will do, you will backtrack from there and you will discard the last entered item. So now your loop comes to node number 2. Now since you're traveling to the left first, you will travel to the right. So you travel to right and you reach 5. You insert 5 in your list. Again, you travel left, you insert 6. Okay, now but once you come to 6, you realize that both the left and right are null. So it means that 6 is a dead end. And at the same time, 6 is not equal to our destination. So it means that we are on the wrong path. So what we will do? We will just pop back, means backtrack from that position. So remove the last entered item, that is 6. Now we are again at 5. Now since left is already explored, we will try to explore the right part. So when we are on the right part, we see the node number 7. Now, node number 7 is actually our destination. Okay, so when once we reach our destination, our work is done. So it means that we have found a valid path which starts from the root and ends at our given node. So after that, we will print our answer, whatever we have collected in our vector. Okay, so that is actually the concept to solve this question. Okay, so in fact, this question I was not able to find on GFG practice platform. So I will just share the code here. Okay, so I have written down the um, yeah, so I have written down the important points related to the question. So we will try to follow something similar to the in-order traversal. So whenever there is null, we return false, and whenever we are also maintaining a temporary vector. So if both are returning false, it means that we are supposed to backtrack and then go do a pop back. So that is the entire gist of this problem. So let me share with you an implementation for the same. Okay, so this slide will contain the code, and you can find the link of this Jamboard, Google Jamboard in your description. Okay, so give me a minute. Let me just put up the code here. Yeah, so let us continue. Sir, I never traverse nearby adjacency list in graph. I use list for that. So how do do it if you are given edge list? So if you're given an edge list, what you do, you convert that into an adjacency list first and then proceed. Okay, because if you're given an edge list, so in the form of vector or vector, so always try to make it a adjacency list. That is because you know how to apply an algorithm via an adjacency list. So try to make into that. Just a minute. Yeah. So in fact, we will be doing a similar kind of problem for the same concept, which is already on GFG. So that is an easier version of this problem. Okay, so let's try to do that, and I will later put up the code. Okay. So the next problem is basically route to leaf path. Okay, so the problem is that you have to basically return all possible paths starting from the root to the leaf nodes. So let's say if you're given this stream, I'm pasting the link of this problem in the chat box. This is on GFC, and in fact, this is an easier problem. So you start from the root and you print all possible paths from root to each and every leaf node. Okay, so I have pasted it in the comment section. Yeah, so the question is basically something like this. You start from the root, print all possible path. Now the question, now you have to print all possible path in the form of a vector or vector. So you see that this is an easy level problem and accuracy of 43%, which is quite great actually. So let's see. So let's say you are given this example in which the node root is node number 2. So you have to reach all the leaf nodes. So the leaf nodes are 12, 5, 11, and 9. So you can reach to 12 from 2 to 7 to 12, then to 5 to 2, then 7, then 6 and 11, then 2, 7, 6 and 5, and 2, 7 and 9 and 12. So in fact, this should be 2, 8 and 9. 2, 5 and 9, 2, 7 and 12, 2, 7 and 12, yes. So there are 4 leaf nodes in this tree. So there are 4 paths starting from the root to each and every leaf node. So you have to output this entire vector of vector. So how will you do this? Any ideas? Hello Naikach, hello Shubham, hello Ravindra, and hello Gaurav. Any ideas that you can use to solve this question? This is also similar to what I just discussed. So basically, you are starting from one node and you are ending at one node. Okay. And in fact, if you look carefully, the time complexity of this problem is n factorial. Okay. No, the time complexity is big O of n. Okay. So, yeah, and the auxiliary height is basically O of s. So that is good. Yeah. So how will you solve this question? So, Naikaj, are you there? Yeah. So, basically, what we will do in this question is we will try to maintain a temporary list. So in that list, what we will do, we will keep on pushing our path. So we are starting from the root, we push the root, then we try to push the next node that is there until we reach a leaf node. So let's see. So as you can see, I will explain it to you all the lines of the code. I declare an array called path, and I declare a vector called paths. So this vector or vector will take care, will contain all the paths. So each and every individual path I will store in this vector in this array called path, and all the possible paths I will store in this vector. So let me rename this vector as answer vector. So I'm storing every individual path in path array and storing every individual array in the answer vector or vector to return. So let me rename this as answer. That will be easier for you all to get it. Yeah. So what we're doing, we are passing our node, we are passing our array and our vector, and also length. Length is basically the index number. So initially we are standing on the root, so I will put the value of the root into my path array. Then I will increment the len as well, the length counter. Now what will I do? I will check whether the left and the right exist. But let's say if the left and right doesn't exist. So what happens? What is the checking condition for a leaf node? The checking condition for a leaf node is that the left and the right both will be null in case of leaf node. So if this condition is becoming true, it means the node under consideration is a leaf node. So in that case, what will happen? Whatever path we have stored till now in our path array, I will push back into my answer array. Okay, so this is the step that we are doing. Whatever it is being stored in the path array should be pushed back into our answer array so that I can return. Now let's say if at least any of them is not null, it means that is not a leaf node. So that becomes a path of a valid path. So I will recursively call the same function for the left as well as for the right. Okay, because the left as well and the right as well, both recursive function will give me a valid path to the leaf node, because all possible paths must end in a leaf node at the right. So that is why we are calling the left and the right at the same time. So this is the concept, and this function called print array is basically just taking care of all the values from the path array and putting it into the answer vector. So this is the concept. Let's see. Okay, so there is a small error. It should be answer. Yeah, so let me submit this problem and check now. Yeah, so as you can see, all the test cases have passed, so therefore this question is correct. So this now this problem is solved. So this brings us to the end of our session. So do you have any question related to the three questions we solved? So we discussed two medium level concepts, and at the same time we discussed an easy problem related to this. So the first one was a medium level question in which we had to count the number of ways starting from the root to any given node. That was a DFS. And then another question of a tree. So, but today's session was quite easier than the yesterday session, in which in yesterday's session we tried to do a hard level question of Dijkstra's algorithm. So today was easier compared to yesterday. So, any doubts here? Let's look into the comments then. Yeah, Naikaj, any doubts here? Yeah, okay. So this brings us to the end of our session. So let me just repeat the initial announcements. So this session will be continuing next week also, and it will be mostly at 10 p.m. So it can be either on Tuesday and Wednesday or Monday or Tuesday. You will get to know if you just subscribe to our channel. Apart from that, we are also having a series on dynamic programming on every Thursdays and Fridays. You can also check that out. And yeah, from 28th of January, that is coming Saturday, we are organizing live mock interview sessions. So on this channel itself, so you will be notified about that. So in case if you want to practice interviews, live mock interviews based on DSA, so that will also be done on this channel itself. So I would request everyone to kindly subscribe to our channel. So that will be very helpful. So yeah, see you all next week then at 10 p.m. Can you please explain the time complexity concept if possible? Yes, it is possible. So time complexity of the last question, I suppose, it will be big O of n because like see there are n nodes. So whatever algorithm you're using, it will traverse all the nodes at least once. Okay, so in fact, if you're traveling from the root node to the very end node, so you're going through all the paths, right? It is not the case that you are repeating any node. That is the idea of recursion. You're using the backtracking concept, right? So you are entering into a path, that path is done, now you backtrack to the next possible path. So you're not revisiting any particular node, so you're visiting all the nodes at least once. So that is the reason, in fact, you are visiting all the nodes only once. So that is the reason the time complexity is big O of n. Did you understand, Shubham, why the time complexity will be big O of n? Because you're not revisiting any nodes. Got it? Okay, that's great then. Yeah, so we are almost to the end of the session. So See you all next week then. Yeah. Thank you very much, Shubham. Thank you, Naikaj. Thank you, Gaurav, and everyone who attended today's session. Yeah. Bye bye.